Hello everyone, my name is Jake, and today I am going to show all of you how to do a nifty little lighting system that I came up with the help of a couple other YouTubers. So let's get started. So first, what I would recommend doing is when you're making any type of game, any type of game really, is to set up a camera first. I would not recommend going through, for example, let's see where we're at here. I would not recommend, oh, I gotta move that up. I wouldn't go the route of opening a viewport and then setting an object and doing all this stuff, because then you've got to do it for all your rooms, and that sucks. So I went ahead and went with a little smooth camera system that was introduced by, I believe it was Sean Spalding on YouTube. Just type his name in and you'll probably find it, like Sean Spalding GameMaker Studio camera or whatever for GameMaker Studio 2. And you'll probably find it. I just added a couple of other things to it. I don't completely understand matrices, mind you. So you're going to have to play around with all of this stuff if you plan on actually putting it in your own game. But I will say that it is important because it does... Our methods for drawing the lighting system is dependent on the camera. So basically what the matrix build look at and the matrix build projection ortho is essentially doing is it's positioning the camera so that it is displaying the drawing surface on the 2D world right above where we want it to be. And basically what I've done here is, instead of just, plugging in the numbers here, I've just created some macros, because this is the width and height of our view, and it's just more useful because then I can go back here, and if I need to change it at all, I can just go back there and change it. So it's important to do these things because it sets up where the camera is located. And like I said, I don't 100% know exactly what this does. You will have to go to Sean Spalding's video because he explains it much better than I do. This just sets the actual camera matrices to where you want them to be. And basically, if you set these values to your view width and view height, how you want the view to be, it will look how you would normally set it up in the viewports and cameras feature down here. It's just a better way of controlling it. Now on to the part that I understand a little bit better is the follow and the I think it's not necessarily lerping. We're not lerping here. I used to do a lerping system, but anyways. So you'll want to define what the camera is following, and you'll also want to define x2 and y2 to just x and y for now. And the next thing you'll want to do, come in here is, and you'll want to mess around with these values as well. Basically, the camera will be following the player sort of at a little lag. Just to make the camera a little bit more smooth looking. And again, this is all in Sean Spalding's video. I don't really want to go through it too much because that's not what the purpose of this video is. The purpose of this video is to show you the lighting system, and I'll get to that in a second. So what you'll want to do is, basically, if follow is not equal to no, meaning if the camera is following somebody, you'll want to set x2 and y2 to equal the basically the offset here that we set up, and then this basically builds, or this basically makes your camera look at where your camera object is located, and then it sets the view matrix. Again, Sean Spalding's video. I will find it and I will put it in the description so that you won't have to find it. So then we move on to our surface, or our lighting object, because this is where all of our lighting system is handled. This gets into a little bit more of my way of doing things. I will say that I did pull a bit of this from other people as well, but most of it is of my own design because I had to tool around with a couple of things. But just because of how my game works, my current project. You will have to do the same, that is a certainty, but I'm just going to show you the basics and then you can figure it out from there. So if you're not familiar with surfaces, basically it's just a different way of drawing something to the screen. What you can do with surfaces is you can create a surface and then draw stuff to it and then basically save it and then draw it at other points or other places of the game. That's one thing you can do with it. Like, say, if you want to print the screen and then have it saved and then draw it somewhere else in your game. I don't know what I would use it for, but I'm sure that you could come up with something. But that's basically what surfaces can do. But for now, my main purposes of using it is for my lighting system. And basically what you want to do when you want to set up a surface is you have to create it in a create event or create it in a step event, which what I'll show you next. I would prefer doing it first off in the create event just so that you have it, because surfaces are finicky. Sometimes they will not exist for random reasons. Sometimes they will delete themselves. Sometimes they will throw errors depending on what you're doing, and it's just kind of a trial and error kind of thing. They're really finicky. But what I did here is I changed my the width and height from my screen to basically do 2 times. And that is because of my camera object here kind of lags behind the player a little bit, and I'll show you an example of that when I get to it. But it sort of lags behind the player, sort of as a smooth camera, and so I just want to make sure the surface is covering my whole screen. So you might want to make your surface width and height a little bit bigger than the actual view of your screen, because you want to make sure that it just doesn't move at a different way than what you want it to. Okay, so once you have your surface created, we're going to get into some complicated stuff. Ignore this glow size stuff for a minute because I'll get to that at the very end. So what a common practice for surfaces is you want to make sure that they exist, because if they don't exist, then none of that will work. You'll have errors and stuff. And like I said before, surfaces are finicky and they'll occasionally not exist for whatever reason. So the way that I have this set up, this new way of setting it up, is you check to make sure the surface exists, and we've defined what the surface is here. We set the target of the surface to the surface that we created here. We set our color to black, which is basically if you're doing like a game where you have a flashlight or a lantern and you want to shine it over stuff and everything else around it is dark, you want everything to be black. And then you set the draw alpha to whatever value you want. This for me changes every level because it's just more dynamic that way, but you can set it to a constant if you want to. You can do whatever you want with that. So the next thing we do is we draw the rectangle at 0, 0, because we're drawing the rectangle at where the surface origin is. And then we're drawing the rectangle with a width of the surface width and the height of the surface height. And then the outline is false. That should say false. That's stupid. Okay, so then we reset the draw alpha back to 1. And another thing that you'll want to do is if you have other colors that you're using, set your draw color back to white or whatever color you have as a default. I believe mine is black already. The default is black, but I'll get back to that in a second. You'll just have to figure it out for your own project. So then next I set a temporary variable called cam, which essentially identifies our camera, which is obj camera, which I have down here. And then we get into some interesting things. Basically what this does, we're going to set in 2 other temporary variables that grabs our cam x2, which is what we defined here, whenever we're following something. And then subtract half the surface width. Well, actually, I should back up a second. If you are not going to be doing this typical camera setup where it lags behind the player and sort of gradually like moves towards them, you're going to want to set up your surface width and height to be equal to the width and height of your view. And you can do that by grabbing probably what is it? There's a function there's a variable that you can grab that will actually automatically grab that value for you. But with mine, it didn't exactly work out that way, so I had to sort of jam in this in here and then do it that way. So what exactly I'm doing here is the way that surfaces work is basically the same as your room. So let me go to my room here for a second. All the way up here in the top left corner is 0, 0, as you could see down here at the bottom left. That's essentially how surfaces work. So for example, if our surface is drawing at, like, say, this part here, 0, 0 for the surface is right here. So, and that's what we have to remember when we're drawing surfaces. So stuff that we're actually drawing to the surface is starting at the surface is 0, 0. So you can't exactly draw stuff to room coordinates because then it gets all messed up. It ends up being in the wrong spot. So that's why we're doing this calculation. This calculation here sets it up to where it lines up with the surface's XY position in the room itself. I believe. And so let's see. Then we move on to these extra temporary variables. I went ahead and I created 2 scripts, one called X in view and one other called Y in view. I did find this little bit on the internet, but I would have done it this way anyways. Basically what this does is you input 2 X values and then it spits out another one. And what this does is it subtracts, what did we do? It subtracts the let's see, it's been like a week or 2 since I actually looked at this, so bear with me for a second. It subtracts this calculation that we do here from our player's X position and Y position, because we do both. And essentially what that does is that lines up our lighting effect so that it draws onto the player's position where it is located on the surface. And to show you the example of what that does, let me set this up again. This is my little project that I'm working on. Let's go ahead and start this. Hopefully this won't take too long. Okay, no, it's working now. All right, blah, blah, blah. Okay. So pick up our lantern, and then this is essentially the lighting part of it that we have set up over our player. I wish I could show you exactly what it does when it doesn't do it correctly. But I'm not sure how I would exactly replicate it. But this is essentially what it looks like when it's over top of the player after we do all of this calculation here. So if it's a little bit difficult to grasp, but if you basically just do it this way and input your own values, it should work. And if you copy my, or not exactly my, but Sean Spalding's camera system here, and then take the X2 and Y2 and plug it in up here, it should work. So then you just do that for the X and Y. Okay, so then we set the GPU's blend mode to BM SRC color. You'll want to do this one because it gives us the effect that we want. There's really no other blend mode that I've used that gives me the correct effect that I want for this. So after you set the blend mode, go ahead and then type reset the blend mode back to normal just so you don't forget it, because that can get a little messy. And then once you do that, reset the surface target just so that you're safe. And then we'll get into this. Okay, so now that we have all that, ignore this line here because that's just a part of my game. What we'll want to focus on is this line. What I have here is we're gonna draw the glow aura onto the player's position, and that glow sprite is that's number 2, is right here. And you can make this specific sprite by using a photo editing piece of software and create a like an explosion gradient. For example, let me pull up paint.net and show you real fast. Paint.net is free if you want it. So then no, that's fine. We can get rid of the entire screen here. I'm gonna go ahead and switch that to that. We're gonna go into secondary and get opacity all the way up. I believe that's how you do it. Haven't done it in a while. You get the radial gradient, go right into the middle of the screen and just sort of pull it out so that it's a glowish effect, and then save it. That's all you got to do for that. It's really nice. It's really cool. If that's what I did for this, you'll want to also make sure that the background is transparent. Otherwise, it'll show up as a giant white block. All right. So you get rid of that. So then basically what I'm doing here is, you can ignore this as well. That's just to make it so that the player sort of, it turns with the player, but that should not be C yellow. It should be C white, I believe. What this does is it draws that to the player's X, and Y that we calculated here in the view, which is equal to in the surface area that we are drawing. So I'm drawing that sprite to the XX and YY, which we calculated here. You can, if you're doing this on your own, you can just put XX and YY if you followed along. Ignore glow size for a second. I'll get to that. Now, this is how you basically would calculate it if you were doing it for, say, a candle or a light fixture that is in your room but is not your player. So what you'll want to do is you'll do with your lighting parent, it would basically be everything that also has, some sort of lighting fixture to it. You'll want to go with that parent. I would recommend setting up a parent for that. And then if it's on or not, or if it is on, rather, you'll do this quick calculation with basically what we did here. It's basically the same thing. You'll take the X position and then subtract you'll basically subtract this value from the X position of your lighting object, and then draw that glow that you had onto that position, and it will draw that thing to that position on the surface. Excuse me. So we did that. Now, just in case your surface doesn't exist, which it sometimes does, usually not, but occasionally, you'll want to put in a catch so that it creates the surface and then set the surface target to the surface that you just created. What I found is nice is to do a draw clear, because this basically just clears the entire screen to black. And then you can do an alpha, which sets it to that. And then you'll want to reset the target like we did up here. So that handles the exception there if the surface doesn't exist. So once you've done all that, you've pretty much got everything you need. The next step you got to do is you have to basically go into your draw end event, and then you can pretty much skip all of this if you want to. This is just an extra thing that I added on at the end, and I'll show you what exactly it does. But you'll want to draw your surface, whatever you named your surface, right here at the dash X and dash Y. You'll also want to bring in this calculation as well for that. I am not exactly sure why it is in here twice. I could probably just, it's probably just easier for information wise. And then this also makes sure that it's another if your surface exists, else create it and then reset it. So that's pretty much all you need to know. Now what I did here is I sort of cheated a little bit, because for this surface, it was let me actually cut this out for a second, because it's really interesting what this does. So let me do that, and then we go in here. If this is the effect that you want, you go right ahead and make it. But what I wanted was a slightly different look. So we have this here. We have our player with the light and then the candle. But it just sort of like cancels out the black and makes it look like a giant aura thing. What I wanted was a little bit of yellow. So what I did is I made a yellow aura in paint.net, about roughly the same size as the other one. And then in this draw, before we draw the surface, we don't add this stuff to the surface so that it doesn't draw on the surface. It draws in the room itself, not on the surface. That's an important thing to remember. These two draw in the room. For example, you see we don't translate this over to here. In fact, that was actually a part of something else I was doing that I probably didn't need. We can just get rid of that little ditty there. So now with those on, we can relaunch my project. And then, as you can see, I'm not quite sure if you're able to see it, but from my perspective, once we actually get two of them on there, that's a trigger block. Don't ignore that. Once we get two lights in there, you'll see that the light sort of adds onto itself because we had that blend mode add on. And it turns the light into a sort of yellow glow. And that is that was the look that I wanted. Of course, if you don't want that look, you can skip right over this part right here, this whole thing. Just this whole thing here, and then just draw the surface. But the important thing to remember is if you get this calculation here wrong, it's all just going to blow up. It's all just going to be wrong. So the reason why I did this is normally if you don't have like a dynamic laggy camera, you'll want to set this to be exactly your width and height, like I did here, global width, global height, and just set it to that. But because my surface width and height is essentially double that of my view, just to be safe, I just take the surface width and divide it by 2, just to take it back to that 200 by 112 that we have down here. And then the same for the Y. That just makes sure that the calculation itself is correct and doesn't say pull from this number exactly, because then it'll be off. Let me actually show you why that won't work right here. Let me show you the consequences of doing this calculation wrong. It's because, see, now you won't be able to see anything. Yep, see? And there's my little message. So it'll show up like up top here or down here. So that's essentially the consequence of not doing these calculations correctly, is it won't show up on the surface. So one final thing, that a little bit of a fun little addition that I made to this is, let me show you on the candle here in this bit. You probably noticed, but you see that little flicker there of the lighting object, or the lighting. That's what this is for. Basically, what you'll want to do is create the glow size variable in your create event. Go into the step event, and on the very top, or you can do this. Actually, yeah, you do that there, because this doesn't affect anything yet. You create a temporary variable called diff, and then you make it choose between 0.01, negative 0.01, or 0. And then you set glow size to plus or minus diff every step. Now what this will do is it will choose between one of these things. So basically it'll add negative 0.01 to this one step, or then it'll do that to the next, or then it'll do 0, etc., etc. And it'll just keep plussing or minusing that value onto the glow size. And the number actually needs to be this low because of what I'll show you later. But then you'll set the clamping of the glow size to equal whatever size clamping you want. And again, it's this size because a glow size of 1 is equal to this exact picture. And then a glow size of, say, 0.9 is exactly 90% of that size there, of this picture, of this glow picture. It's 90% the size of it. So then what you do with the glow size is you take it down here to your draw sprite ext with the glow and the positioning here, and you just plop the glow size in, the glow size variable. What this essentially does is it adds that little glow effect, but the clamping ensures that it doesn't get too small or too big. And I'll actually back that off, and I'll show you exactly what it looks like if you don't clamp it. It gets a little weird. If you leave it alone for a little while, at first it might not do anything, but if you leave it alone for a little while, it'll get really big or really small. So it's always better to just sort of clamp it in between two values, otherwise it'll get out of control. It doesn't seem to be doing that much right now, but you really, really don't want to leave it untamed. You kind of want to keep it in check here. And then you'll likewise want to set your glow size variable inside of your lighting object so that it does it for the lighting objects as well as the player, because all we're doing right now is just the glow size for the player. And that's strictly only for fire lighting. You probably don't want to do glow size for your flashlight objects. But I don't have any flashlight objects in my game, so that we're not going to be dealing with that. And I believe that is everything that I have for this. We went over that. We went over the matrix. We did the create, the step, and the draw. So yeah. Like I said, I will be posting links to the specific videos or websites that I looked at for this specific lighting example in the description. So if you have any issues with it, I am sure that there is something you can learn from those links. But regardless, that is it for this video. I apologize if this was really long, but I had a lot to cover. Anyways, thanks everybody for watching, and I hope you enjoyed watching this, and I really would like to see your little lighting system that you created from this little tutorial in your own games. I would really like to see that. Anyways, thanks everybody for watching, and I hope to hear from you soon. Thanks.